I created this lesson actually on the weekend because I was worried that after spring break last year, there may be some gaps in your math knowledge. So I called this review of math skills, but in my mind, there's a little question mark next to the word review because some of you might not have seen this. This is some of the skills you want to have kind of at your fingertips. So welcome to Physics 12. During this course, we're going to use models, often mathematical, to help us understand a particular set of phenomena. And as I told you last year, these models will almost always be wrong. We'll ignore air resistance, sky, still, or we'll ignore friction or whatever. But they're going to be pretty good approximations. They'll be close. And since especially this year, our models will be more and more mathematical, good math skills are helpful. Here is a hopeful review of some math skills. One of the things you have to be able to do is solve a quadratic equation. But first, I need to ask, what is a quadratic equation? What makes a quadratic a quadratic? How can I glance at an equation and tell you two things? Number one, it's the graph of a parabola, and number two, that's a quadratic, because those kind of are the same thing. Psst, psst, look up, look up, look up. More specific. It's got a squared. The variable has a squared. By the way, if it's got a cubed, we call it a cubic, not a quadratic, and there's a whole different method to solve that. We have this thing that we call the quadratic equation. And it's on your formula sheet on the back page, I think, so you don't need to memorize it. I know when I taught Math 11 Sky, I always made my students memorize it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I always tried to challenge students to say it as fast as possible. X equals b plus or minus square root of b squared minus 4ac all over 2a. I would say it backwards, a2 overall. I'm out of practice. ca4 minus square b negative root square minus plus b negative equals x. No, I stuck a negative in the square root. I shouldn't have. Why do I love the quadratic formula so much? I used to make the joke when I taught this to students that this was the quadratic formula was the iambic pentameter of mathematics. It was as close as you got to Shakespearean mathematics because it's the only one of its kind. There is a one formula to rule them all, ring of power, that will solve any squared equation. There isn't one that will solve any x cubed equation. There isn't one that will solve any x to the fourth, x to the fifth. And in fact, for about actually longer than that, for centuries, mathematicians were looking for an x cubed formula or an x to the fourth formula as opposed to just the quadratic equation. And it was only proved, I think in the 1880s, there won't be one with higher exponents. It's a complicated proof. It's the only one of its kind. So, how do I recognize a quadratic? It's got a squared. Okay. Where's the quadratic that we're going to be dealing with? Don't write this down. Plus a half a t. What? There it is. Okay. Last year, if I asked you to solve this for t, I had to make vi 0. Because that you can still solve with Math 9. Not this year. So how do we solve a quadratic? First of all, we have to recognize it. So I always ding the squared. It's quadratic. Who remembers how you solve a quadratic equation? There was a first step before you did anything else. So if you want to, you can make a little note here. Step 1, make equal. You have to make it equal to what? Step 1. And you're going to find actually for anything except a boring equation, you have to make it equal to 0. So anytime you have an exponent, step 1 is going to be make it equal to 0. How could I make this equation equal to 0? I could move the 5t squared and the positive 7t over, but what would be the easier way to do it? So I'm fine if you do that step in your head and just write down 5t squared plus 7t plus 2 equals 0. But I would encourage you, Josh, write the squared term, then what we call the linear term, and then the constant term. Go in descending order of power. Okay. Do you recall me occasionally last year saying lazy but organized? I'm going to be lazy but organized. I will almost always write out the quadratic formula because it is easy to get wrong. So I'm going to, first of all, the quadratic formula says x equals, but what letter is sitting where the x is here? Can I write t equals? If you write x equals, I'm not going to take marks off, but it's a pet peeve of mine. No, you're not solving for x, you're solving for t. Okay, so I'm going to go t equals, and then the quadratic formula says negative b plus or minus square root of b squared minus 4ac all over 2a. This is one of the few times where I am going to write extra stuff because I've made so many dumb mistakes. But now I'm going to be lazy but organized. Don't write this next bit down. You may have had a math teacher last year who said, and now I'd like you to write down what A equals, what B equals, what C equals. And if you want to do that, Cleo, go ahead. Here's what I usually do. I always say, hey, that's A, that's B, and that's C. I mean, they're sitting right there. And I put them in order from biggest to smallest on purpose. I'll do that. If you really want to make it obvious, you can draw a little box around them. I generally don't. Just make sure you notice if there's a negative in front of them, the negative goes with it, right? I should ask, you all have seen where the quadratic formula is on your sheet? Now, this one we're all going to solve manually, and then those of you that have the solvers, I will show you how you can use the solvers from now on, because you were willing to spend a little extra cash. For now, Sky, what's b in this equation up here? And I'll be fussy. Positive 7. I noticed the plus sign. So positive 7. So what's negative b? Plus or minus square root of. I usually will try and do b squared in my head if it's a nice number. And I'll show you another trick that I'll often do. When I square something, I know the answer is always positive. So if I was writing this out, I wouldn't include the negative here. But anyways, 7 squared, 49, minus 4. Sky, what's A? And what's C? All over. And then I'll often do 2a in my head. Carter, I can multiply any number by 2 in my head, even if it's a yucky decimal. So I will often choose to go 10. The big one that's going to show up there in Physics 12, typically in front of the t squared, is going to be the acceleration. Who remembers, what is the acceleration due to gravity? Often a is going to be a negative 4 because it's a half at squared, it's going to be a negative 4.9, and so 2 times 4.9 will be 9.8. And so I'll often do that in my head because William, lazy but organized. Okay. Typically what I'll do next is I will evaluate what's inside the square root. I won't do the square root part yet, but what is 49 minus 4 times 5 times 2, please, on your calculator? I can do that in my head. It's going to be, is it 9? Yeah. Can you take the square root of 9 evenly? That tells you could also have solved this one by factoring, which is the other method you learned last year. We're not going to often have ones that will factor in physics because I'll be trying to use real world data. So in math, I would always have told you try factoring it first. In physics, go straight to the quadratic formula. Now, I know the square root of 9 is, everybody, but what if it had been a yucky number? I'll show you how we would type this in. So now I'm going to say t equals, and I'm going to get out my calculator. Is this a fraction? No. Is this a fraction? Yes. Is there more than one thing on the top? So brackets around the top, or use your fancy schmancy two-level fraction button. But I'm going to go bracket -7, and I usually do the plus 1 first. Square root of 9, I have to close off the 9 square root on my calculator. I have to close off the top, divided by, is this a fraction? Yes. Is there more than one thing on the bottom? Don't need brackets around the bottom. And I get -0.4. Now, what you want to figure out on all of your calculators, somewhere, if you read the manual, you should be able to backspace and bring back the previous line. Because it sure is nice if you can do that and just change the plus sign to a, because it's plus or minus. Make sure you put a minus there and not a negative, because that's different. And you'll get your second root, your second solution. -1. Ta-da. This was made up numbers, Cleo. Typically, you'll have much yuckier numbers than this. Okay? Let's do another one. B. What kind of an equation is this? It's a quadratic. How do I know just by glancing at it? It's got a square. Yep. To solve a quadratic, what's the first thing that I have to do before I do anything else? Make it equal to 0. Okay? Now, look up. Here's Mr. Dueck's peeve. I have done so many quadratic equations in my life. I know when I'm going to make a dumb mistake. I'm far more likely to make a dumb mistake, Karn, if the squared term is negative. I don't know why, but I do. So I will almost always try and keep the squared term positive. I'm going to minus the 12t over. Is that okay, Sky? What's A? I'll put a little A there. What's B? -12. Oh, what's C? 0. If you want to, you can make a little, or you can just internalize that. I don't care. T equals -b plus or minus the square root of b squared minus 4ac all over 2a. What's -b? What's -12? Are you positive? Plus or minus the square root of b squared. What's b? No, it's not. Okay, look up. Everybody look up. Keep looking up. We ran into this problem last year. If you're not careful on your calculator, if you go -12 squared, what is -12 times -12? What's a negative times a negative? And 12 times 12? How come I got -144? Okay, I either, if I'm squaring a negative, have to put the negative in brackets, Or because I know the negative is going to vanish, I might be tempted, even though it's technically wrong, just to write 12 squared for b instead of negative 12 squared, because I know the negative's going to vanish anyways, and that way I don't make that dumb mistake on my calculator. You know what? I'll write negative 12 in brackets squared, but you know what I'll type on my calculator, Sky? Just 12 squared. Why didn't I write minus 4ac? Oh, c is 0? So what's 4 times a times 0? 0? Don't waste my, I think last year I said, don't waste my time, or something like that was what I always said, right? All over 9.8. I know that 2 times 4.9 is 9.8. By the way, this would be maybe some kind of an equation where we were launching a projectile downwards from ground level. Don't quite know. I was making up numbers. This isn't a really good physical situation yet. Okay. Is this a fraction, Sky? I don't know why I'm picking on you because you're in front row. I'll pick on somebody else. Well, Sean, is this a fraction? Is there more than thing on the top? Bracket 12 plus square root of 12 squared, close bracket. Now, I know the square root of 12 squared is just 12 divided by 9.8. Oh, I got mismatched brackets. On my calculator, I have 2 open brackets, only 1 closed bracket. I forgot to close off the top. I think last year I said always take a final inspection before you hit equals, right? 0. No, what did I get? Sorry. 2.448, that there? Is that right? How many sig figs? Well, 2 or 3 unless you know you're going to use it. If I know I'm going to use this to calculate something else, 5 or 6 sig figs. But for now, I'll go 2.45. Actually, well, yeah, 2.45. Backspace. Change the plus to a minus. And I think you get exactly 0. Question, Karn? No? Okay. Oh, what makes a quadratic a quadratic? Squared. What is a squared as an exponent? How many answers did I find? 2? If you're solving a cubic, how many answers do you think you're looking for? 3? If you're solving a quartic, how many answers do you think you're looking for? That's called the fundamental theorem of algebra. It says the degree, the exponent of a polynomial equation tells you how many answers you're looking for at most. Hashtag nerd trivia. What kind of an equation is this? Quadratic, how do I know? It's got a squared. First thing I'm going to do is make it equal to 0. Now, I got to be honest. Although the least amount of work would be to plus the 10 over, I hate having that squared term negative because that's when I make stupid mistakes. So I'm going to plus the 4.9t squared and minus the 12t and just leave the negative 10 where it is. Is that okay, Aiden? I'll get positive 4.9t squared minus 12t minus 10 equals 0. Mark, what's A? What's B? What's C? Now I'm going to pause the video for just a second. Alrighty. T equals negative B plus or minus the square root. But here's the key. You have to be able to solve a quadratic. I don't care how. You have to be able to solve one of these. And it has to be almost trivial. In other words, I can solve this. It's just going to take some time. Boring. But always getting the right answer. So negative b, I guess positive 12, plus or minus the square root of negative 12 squared minus 4 times 4.9 times negative 10 all over 9.8. You could write 2 times 4.9 down there too. For those of you that don't have the solver, I played around with a bunch of different ways of doing this. I think it's worth evaluating what's inside the square root first and doing one more line of work. So I typically go 12 plus or minus the square root of whatever the heck that's going to be. And on my calculator, I would type either in brackets negative 12 close brackets squared, or again I might just 12 squared because I know the negative is going to vanish, minus 4 times a times c. And I get inside the square root 340. If it was a yucky decimal, I would carry as many sig figs as I possibly could here. Now I can say to myself, self, is this a fraction? Is there more than one thing on the top? Brackets around the top. 12 plus the square root of 340, close off the square root, close off the top, divided by 9.8. So one of the answers you all got positive 29481. I'll go 3.106. And then I'm going to backspace Aiden and edit because I can. Negative 0.657. Now, if this was your math class, that's what you would report. Wes, what variable did we solve for? Not x, but what? What did t usually stand for in physics? Can time be negative? So if I was doing a physics word problem and I ended up having to solve a quadratic to solve for t, I would chuck the negative time. That's how you know which one to use for the rest of the question. How many of you got that okay? Okay. So those of you with a solver, be a little smug. Those without a solver, got to figure it out. So, solve equation D however you want. I'm going to do it up here by freezing my screen. Let's look up and see if we end up in the same spot. I can always tell who has the solvers because their pencils drop so much faster than mine does. No, that's wrong, Mr. Duick. You missed a symbol. Get what I got? Let me know. I might have made a mistake because I always use a solver if I can. Am I wrong? I'm right? People with solvers got the same answer as me because those are the ones I trust? Okay. You can ignore that -8 thingy. I made a typo initially. Is that okay so far? Quadratics. Okay. Here's what that really means now. I can launch objects from a cliff. I can ask you to solve for t, but I don't have to drop them from the cliff now. I can launch them from the cliff. Last year, anytime we were on a cliff, VI had to be 0 if I was asking you to find t. So that's skill number 1, good old solving a quadratic. Skill number 2, we called formula manipulation. This was the ability to look at an equation and rewrite it in your head. And I really pushed that last year, Noah, because I made the argument it really cuts down on your memorization, helps you understand how everything fits together better. So, if I gave you AB squared plus C equals D, and I said, get the A by itself. Here's a nonsense equation. How would you get the A by itself? First thing, what's going to drop down like a domino? The side the A is not on. So I might be tempted either in my head or actually in my homework notes to go equal, the D is going to drop down. And then the phrase I told you last year was, it's reverse bedmass. So I heard somebody say divide, not before I do any adding subtracting, because in bedmass, I do the dividing, multiplying before the adding and subtracting. Reverse bedmass, it's going to be the opposite. So I'm going to do some adding and subtracting first. What? And in my imagination, don't write this next little bit down, I see that sitting there just in my imagination. I want to get the A by itself. How? So, yeah. And I think you came to agree with me, although it seemed terrifying at first, Karn, I think you came to agree with me. It was way better than trying to memorize every equation. Just get comfortable with some algebra and learn to rewrite stuff. This year, we will often be doing questions where I won't even bother with numbers. I'll say, there, we've derived it. We have a new equation. Now you know how to derive it on your own if you need it. The numbers are incidental, as far as I'm concerned. B, we did last year. Solve D equals VIT plus a half AT squared for T if VI equals 0. What kind of an equation is this? It's a quadratic. If VI isn't 0, you can't get the T by itself. You have to use the quadratic formula. But since VI is 0, we really have this. D equals, and you could either, Cleo, write a half AT squared, or you might recall that I preferred to write that as AT squared over 2, because to me that looked prettier. Cleo, what do they want me to get by itself? Solve for what? What side is the T on, left side or right side? So what side's going to drop down like a domino? Left side. Ka-thump. Heck, I'll even put the equal sign there so I've got my little pivot point. How will I move the a over? Sorry? Yep. How will I move that 2 that's on the bottom over? Yep. Now, that gives me a t squared. How do I get rid of a squared? By the way, how would I get rid of a cubed? If I get rid of a squared by square rooting, how would I get rid of a cubed? Cube root. We will need to pull out the cube root, and it will actually be useful later this year when we look at orbital mechanics. And you will see joy and glee on my heart, because anytime I get to show you where another button on your calculator is, oh, my little math nerd heart just goes pitter-pat there. When we start to look at orbital mechanics, what we will often have is one big fraction equals one big fraction, like c. So, a squared over bc equals d over e. How would I get the e by itself? First of all, where is the e right now? On the? Where on the right? On the, look at where it starts with the letter B. Blech! We will never try and deal with stuff when they're in the bottom of a variable, of a fraction. We always want to get it to the top. Well, dividing by e on the right is the same as doing what with the e on the left? So in my mind, don't write this down, but look up, I see a squared e over bc equals d. Can you see that just in your imagination? Good, get the e by itself. How will I move the a over? Sorry, the a squared over. Am I getting rid of the squared? Am I getting the a by itself? So how will I move the a squared over? What's the a squared doing to the e? Timesing, so? How will I move the bc over? You're right, loud and proud. Yep. You get this. E equals, I'll write it alphabetically, BCD over a squared. And now I'm going to zoom into the typewritten fraction really big. I'll come back to the answer in a second, but see this? Look at what we wrote for the answer. If you want a handy little back pocket tool to pull out, when you have one fraction equals one fraction, stuff moves diagonally across the equal sign. In other words, if I was doing this one, I would have gone like this. And I can walk away from there. Oh, we'll be using that one a fair bit later this year. Okay, so handy shortcut. This is, by the way, in grade 8 you called it cross-multiplying, but I'm cross-multiplying now with a vengeance. Let's do whatever we need to here simultaneously. If I have one fraction equals one fraction, I can move terms diagonally. Now, I have to have one fraction equals one fraction. I couldn't do it here because I don't have one fraction equals one fraction. I have two fractions equals one fraction. Doesn't work. Trig. How many of you last year did sine and cosine and tangent? Okay, this is just be honest with me. How many of you have no idea what I'm talking about when I say sine, cosine, and tangent? Has everybody done at least a little bit of, if I say SOHCAHTOA, does that ring a bell? Okay, so I'm brushing cobwebs off, not teaching from scratch then. That's good, that's good. Trigonometry is the study of triangles. And you're going to find this year, when we have something moving at an angle, let's say like that, we're going to choose to break it up into moving that way and moving that way at the same time, because that way we can use physics 11, because in physics 11, Aiden, we could handle stuff moving left and right. We could handle stuff moving up and down. Why deal with stuff moving at an angle if I can turn it into a physics 11 question? So can you see we're going to be having triangles pop up quite a bit? Hence trigonometry. The two main tools that we're going to use are Pythagoras and right-angled trig, which you probably in Math 9 or 10 called SOHCAHTOA. There is also a sine law and a cosine law when there's no right angles. And if you're a nerd and you want a shortcut sometime during a Y block or a blended session, I can walk you through it. That's how I do it. But for now, you can survive and get 100% in Physics 12 using nothing but Pythagoras, which I would argue is Math 8, and SOHCAHTOA. So example 1 says, find the length of the missing what? How? What did they give me? 2 sides. Okay, if you give me 2 sides, I can find the third. And in order to use this, in order to solve this, we use Pythagoras. Which begs the question, what is Pythagoras, Mr. Duke? Someone said it loud and proud there. This is frustrating because I can't see whose lips are moving, and someone back there is saying, was it Mark or was it Cleo? Loud and proud? It's one that people kind of remember because it's alphabetical. Did I give it to you on your formula sheet next to the triangle there? Right, I think right where the quadratic formula is. Did I? Or not? Is it there? I can't remember it because it used to be on the provincial exam one, but I might have taken it off because I was so disgusted that they gave it to people. Did I give it to you or not? I'm not hearing a conviction here. Okay, I'll have to go check myself. Mark cleverly said a squared plus b squared equals c squared. But there's one more thing you have to remember. What always has to go where the letter C is? The hypotenuse. The hypotenuse. Which one is the hypotenuse? Okay, so I will often put a little C, little A. A and B doesn't matter. You could have put the A where the X was and the B where the 55 was, but I'm lazy but organized. If I'm doing Pythagoras, I might take the time to do that. As an equation, now I'll be honest then. I would do this. I wouldn't write this out in my homework. You can. We're doing this in our notes to jog our memory. I would probably go straight to 55 squared plus X squared equals 73 squared. I would probably jump straight to that. Nick, what am I trying to get by itself? Eventually, first I'll get the x squared by itself. How would I move that 55 squared over? What's the 55 squared doing to the x squared, Nick? Is it multiplying? Sure, no. What? So how will I move the 55 squared over to the other side? So I would go like this. X squared equals 73 squared minus 55 squared. And I would go to my calculator now. And I would type 73 squared minus 55 squared. I would hit equals. What does x squared equal? What'd you get? Anyone? Loud and proud, what? 2,304? 2304? I'm not done. That's x squared. So, next step. Square root. This might work out evenly. What'd you get? 40? 48 even? Units, centimeters. I have no problem, Ariana, if you choose to do that. Write 1, 2, 3, 4, 5 lines. Go ahead. My goal for all of you is that you can write A, B, and C, go straight to your calculator and write down the answer. You're either going to be finding one of the sides, in which case it's hypotenuse squared minus the other side squared, or you're going to be finding the hypotenuse, in which case it's side squared plus side squared, and then square root your answer. So here's what I would do. Am I finding the hypotenuse, Noah, or am I finding one of the sides? It's going to be this squared minus this squared equals that squared square root. And I would, if I could, go straight to my calculator and go. Now, on a test or a quiz, Sky, I'd obviously show more work, as always. But in my homework, 19.3 squared minus 7.6 squared equals square root, answer button equals. And I get 17.740. I would do that. Now, that's a little quick, I know, for some of you. Let me first of all paste that in here. You're seeing I'm looking for moving desks on Amazon right now. Once COVID's over, I'm getting a new sound bar. I want to see if I can make this platform mobile so I can teach from wherever I want. Go wireless.
How would you move around the class?
Pardon me?
How would you move around?
I'd have to wear a mask. So this would be once COVID's over, or I'll carry it. My dream is to teach from behind you so you don't know where I am.
No, like, because you're moving the desk with you, right?
I would probably move it ahead of time and just pick a station somewhere and teach there. It's on my list of things to try. Is that okay for Pythagoras? Okay. We're going to be using that about a gajillion times in the next month. Okay. And again, it's either, if they're asking me to find the hypotenuse, that squared plus that squared equals square root button. If they're asking me to find the leg, hypotenuse squared minus other leg squared equals square root, answer button. That's when they give me two sides, find a third. But you also learned last year or the year before, they can give you one side and an angle. But to do that, you had to be able to label triangles. So it says this, you learned that there are three sides to every triangle, and we called them opposite, adjacent, and hypotenuse. O, A, and H is typically what I used. But it depends which angle you choose. So it says label the following triangle with opposite, adjacent, and hypotenuse. I often, when I see which angle I'm looking at, just to help fix it in my brain, I will often go color, 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 color. Takes 1 second. And hey, I get the color. Which one is the hypotenuse? Left, top, or bottom right? Hypotenuse is the longest side. It's also always across from the 90. You can kind of imagine that the right angle symbol is an arrow pointing towards the hypotenuse. Okay, the top side here, opposite or adjacent? How do I know? Well, the word opposite means facing. Sky and I, right now, are opposite each other. The word adjacent means beside. If you are sitting at a lab table with someone else, the two of you are adjacent to each other. So here's my angle. Both these two sides are adjacent to the angle. Why can't it be this long side? Because it's already the hypotenuse. This has got to be the remaining adjacent side. So step one, Josh, is you've got to be able to label a triangle with opposite, adjacent, and hypotenuse. Don't write this down. Look up. What if instead of that angle, what if theta was up here? Color, 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 color. Does the hypotenuse change? What would I call the short side here? Opposite. What would I call this? Okay. You've all seen that before, I hope? Okay, good. Let me bring back the original diagram. Color, 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 hypotenuse, opposite, adjacent. We also have three primary trig ratios. What are they called? Sine, not sin. Sin is when you swear in my class. Cosine, abbreviated cos. And tangent, abbreviated tan. By the way, there's also three more trig ratios. There's cosecant, secant, and cotangent. They're the reciprocal of these three, and they come in handy later on, but you can survive just fine without them. One of the things all of you need to be able to do is evaluate sine or cosine or tangent on your calculator, and you need to make sure your calculator is in degrees. Thanks, Carter. I'm not sure how much further I'll get. I'll do a bit, but we'll put it online. How do you find sine of 42 degrees on your calculator? Well, if you have a good calculator, and all of you do, you can type sine 42. Mine automatically opens a bracket. Yours might not. So I have to close the bracket off. But can all of you right now find the sine of 42 to 4 sig figs? You get 0.6691? 306? Okay, 0.6691. Is there anybody who did not get that? It means your calculator is not in degrees. Who is taking pre-calc this quarter? Pre-calc 12. You are? There may come a time in pre-calc when you're doing trig, and there you might be in radians, because that's how we typically do angles in Math 12. You'll just have to get in the habit whenever you're doing trig homework or a trig test, physics homework or a physics test, make sure you're in degrees. For math, make sure you're in radians. Years ago, I had a student sitting right where Cleo is right now, named Jordan Sakila, really nice kid, one of my top kids ever. And it was our Physics 12 final exam. It was in June. It was hot and muggy in here. It was all quiet. And in the middle of the exam, about an hour in, we heard a noise. It's a tough noise to describe. If you can imagine a cow being fed into a wood chipper while it was still alive. It was Jordan, and without looking up, I just said, oh, and make sure you're all in degrees, not radians, because he'd been doing my Physics 12 test in radians and just getting nonsense answers, getting negative answers, and just thought he was doing everything stupidly wrong. No, he had the wrong setting on his calculator, kind of like Cleo does right now. Come fix that. It was 0.6691. Can you do the next three on your own real quick? I'll do them up here. What's going on here? And you should find something weird happens somewhere along the way here. I think you should find D is a bit weird. I hope. Did you get 0.2419 for B? And exactly tan of 45, that's another one I've memorized. I know the tangent of 45 is 1. Pardon me? Because your opposite and your adjacent are the same length in a 45-degree angle because it's an isosceles triangle. So anything divided by itself is 1. Good question. What happens when you tried going tan of 90? Error. What's the tangent of 89? Let's try sneaking up on it. What do you get? What's the tangent of 89.9? Bigger? What's the tangent of 89 point and then 4 nines after the decimal point? So 89.9999. Bigger? If you had to make a guess as we get closer and closer to the tangent of 90, what happens to our answer? It shoots all the way off to, as a graph, it goes dead vertical and shoots off to infinity. So the tangent of 90, undefined. Or if you really, really want to be calculus, you could say it's infinity, which we write with as an 8 on its side. By the way, that also means that will never show up in a real world physics problem because I don't know how I'd set something like that up. You also learned not only can your calculators go forwards, if I give you the angle, you can tell me the trig function. You can also go backwards. I can tell you the trig function value, and you can give me the angle. So suppose I told you that we had hit the tangent of a mystery angle, and our calculator told us the answer was 3.732. Who remembers, how do you go backwards and find an angle? It's going to be either shift or second function or inverse, depending on your calculator brand. But yeah, it's going to be hit the second function or the inverse or the shift button, tan, because that's what they, trig function they gave me, 3.732. And that will tell you the angle we came from. 74.999. What did I really start with, do you think, when I made up this question? Not 74.9998, but yeah, 75 degrees. So in example 5, here, compare it to example 4. Example 4, I gave you the angle and I said, tell me the trig function. In example 5, I'm giving you the trig function and saying, tell me the angle. So here is where we're going to hit the second function or the shift button. Try these 3 on your own. I'll do them up here, and let's see if we end up in the same spot. Noah, you get those okay? First 2 I did in my head. I might be wrong, but I'm pretty sure I'm right. Oh, Noah isn't even trying. Did I give you your calculator? I didn't. I'm sorry, Noah. That's my fault for forgetting because I'm getting old. Is that okay? So far, so good? Yeah. Okay. I am going to pause here, sort of, because I'm not going to get through the rest of the trig review, and I've been talking at you, and it's a Friday. But we have reviewed how to solve a quadratic and some formula manipulation. If you want to get a head start on the homework, the first bunch of questions are all trig, but then number 9, A, B, C, and D are quadratic equations that you can try solving. I don't care if you use the solver or if you do them by hand. And then number 10, A, B, C, and D are some formula manipulation questions. And I did include the answers. You can also try the trig if you think you remember how to do it, but I'll review the fundamentals of SOHCAHTOA trig first thing, what do I see, block D? First thing Monday afternoon. Yes, that's what we decided? Yeah. So we'll go Monday afternoon. And then I'll probably get partway into lesson 2 on Monday afternoon as well. Does that work? Thank you for your patience. That was a lot of me talking.